Thank you for joining and tuning into us. We are here to present our physics paper 2 from Nyaga Secondary, and we are thrilled to have you on board. Welcome. Meanwhile, you can have this program, which is very important, that we shall be having a 5-week session of engagement in science and mathematics. So you can make an inquiry through the number on the screen. So here is now the paper, our physics paper 2. Then you're going straight to question 1 in section A, which comprises of 25 marks. We have section B, which is of several questions, totaling up to 55, a total of 80 marks. You can have my number on the screen where you can make inquiries after the upload. Then question 1 in section A reads, state the property of light. State the property of light associated with formation of shadows. This is light in physics form 1. Then a shadow will be formed when a light path is blocked by an object. And this tells us that light travels in a straight line. So the property is that light travels in a straight line. It travels in a straight line. Properties that are used to determine whether an accumulator requires recharging or not. We have the relative density as the first point. And we have the second one, where we have the voltage output. In case it falls below 1.8 volts per cell, then it means that it requires to be recharged. So explain why soft ion keepers are suitable in storing magnets. When it comes to be like this, we know that we have the keepers which are arranged in this manner. Then we have some magnets. So this and this, they are the keepers. And we have this one as a magnet. And still this one is a magnet. So this is how they are arranged. That if this is a north pole, this becomes a south pole. And this becomes a north pole, and this becomes a south pole. Therefore, we know that they are going to acquire opposite polarity. For example, this part will acquire a north polarity, this one a south polarity. this one a south, and this one a north. So at long last, all the magnetism will be forming a loop. It's going to be forming a loop, and this will lead to retainers of the of the of the magnetism. Therefore, we can say the dipoles of the keepers form closed loop or complete loop with those in the magnets ends protecting the magnets down be we can say from the magnetization, sorry, from the magnetization, like that. We have question 4. The figure below shows a conductor, carrying current placed in the magnetic field of two magnets. Then you're told complete the diagram by showing the field pattern and the direction of the force F acting on the conductor. So in this case, you're going to apply the Fleming's left-hand rule. And in this case, we know that the first finger will be showing us the field. Our second finger will be showing us the current. And then our thumb will be giving us the direction of the force. Will be showing us the direction of the force. Allow me share the links. So, how will this one be happening? Allow me. The first thing is you need to look at the direction of the current. When you are having a cross and a circle, this means current into. Then a dot and a circle, it means current out. So from the diagram that we are having here, we can see that it is giving us current out of the paper. So now, the moment we'll be applying the Fleming's left-hand rule, then this is how I'm going to place it. So allow me show you from this part. I don't know if I'm clear. Yes. So if you look at my hand clearly, then I'm going to place it in a manner that my first finger, this one, will be showing the direction of the field. So from the left side, where we are having the North Pole, then we are supposed to be moving to the South Pole because that is the direction of the field. So from the way the diagram is, I'm supposed to place it like this. I'm supposed to place it like this. So this will be the field. Then this is the current out of. This is the current out of. And then this will indicate the force or the resultant force. So now my finger is matching what is on the diagram. Current out, direction of the field, and this will be the resultant force. So back to the paper, then this is what will happen. So the direction of the field will be like this, from North Pole towards the South Pole. And then we have something that we need to note. Since the resultant will be moving upwards, since the resultant force will be moving upwards, like this. Then we need to ask ourselves, then from which side are we going to be having a stronger field? So at the bottom, we are going to have stronger fields. Like this, which are somehow close together. And then on the upper side, then we are going to have the weak field. So how can we indicate that we are having a weak field? Like this. So the next line, I'll draw it like this. So this is a weak field, whereas at the bottom, this is a strong field. And at the top, we are having weak field. Like that. So you indicate this one as our F. We're having our question 5. We're having our question 5. But before then, we can have these adverts on the screen. Yes, now we can continue. So now we are having and this one is of the convex mirror, where we are entitled to locate the object. So we are told complete the ray diagram to show the position of the objects. So you can see where we are having our image forms. So we need to follow the rules of the rays that are being applied. Therefore, since we are having the image, we need to trace back the object. So we are going we are going to use reversibility. Therefore, in this case, we'll be having uh, the first ray, which is a ray uh, is close and parallel to the principal axis. Then it is reflected through F. So now I must identify that which is reflected through F like this. So since the then my ray will be like this. So now from these sides, I'll be able to trace. I'll be able to trace array that is close and parallel in this manner. Then I'll be able to locate it in this way. So it was in this direction, and then it was reflected back in this direction. It was reflected back in that direction. Then we have the second ray, which is a ray that must be through the center of curvature. In this case, the ray will be reflected back through the same path. So now I have to draw it and make sure that it is touching or it is through the C and also touching the tip of the image. So this will be in this manner. Like that. So now I'll draw my object here. Like that. So this becomes my object. The ray direction, it was to and fro because it can be traced back through the same path. Can be traced back through the same path. Okay, now we can continue to the next part. Meanwhile, you can have these inverts. Just briefly, and then we proceed. So now we can proceed to question 6. You are told that the figure below shows a displacement time graph. Shows a displacement time graph for a wave with a period of 0.5 seconds. With a wave of a period of 0.5 seconds. Then you are told determine the velocity of the wave. So there are some things that I am going to adjust, that this becomes displacement position graph, so that in this side we shall have distance. So on the left side, the y-axis, we are having displacement. On the lower side, which is the x-axis, we are having distance. And this distance, we are supposed to give or award it in terms of centimeters, like that. So now, you are told to determine the velocity of the wave. The first thing, you are supposed to analyze the question. And from my point, we can say that t is equals to 0.5 seconds. So we can get our frequency, which will be 1 over t, and this is equivalent to 1 over 0.5, and is going to lead us to 2 Hertz. Then from the diagram, we can identify what will be the wavelength. So having frequency, then what will be our wavelength graph? So from here all the way up to here, we can have a complete wavelength. And our diagram, we are having the distance given in centimeters. So from here, assume it is 0 points here, then it becomes centimeters, which is equivalent to 0.2 meters in SI units. Therefore, from the formula of V is equals to F lambda, then we can substitute and say that we're having our 2 Hertz times 0.2 meters. So this becomes 0.4 meters per second. 0.4 meters per second. We can go ahead to the next question. State one factor that affects the speed of sound in water. State one factor that affects the speed of sound in. So now we know that we have several. We have temperature of the water. We have another density of the water. We need to be specific. What temperature are we talking? And what density are we talking? An electric bulb rated 75 watts is operating on a 240. It is 75 watts, 40 volts. Then we ask, determine the resistance. That is our question. What will be the resistance? So you need to know all the formulas that can lead you to power, where we can use a voltage, where we can use resistance. I can see I haven't worked out this one, but it is very easy. So we know that we have several methods where we have power is given as VI. Power is given by I squared R, and the power is given by V squared over R. Then we just need to pick what is our question. Therefore, our power, which is of 75, we can use this formula. Power is equals to V squared over R. Then you can have what's as 240 divided by R. So making the R the subject of the formula, R the subject of the formula, it will be 240 squared divided by 75. And then this one from computation, since I had not worked out from my work, from my paper, allow me compute it right away now. So 240 by 240. Then you divide by 75. Then we are having 768. 768 ohms. This is something that is a very large. This is a very high resistance. But we can still prove if we can still arrive at 768 by getting the current. So 768 will be the same as V, which is 240 divided by I. So I will be the same as R is equals to V over I. So I will be the same as V over R. So 2 divided by R, which is 768. 240 divided by 708. We are going to get a current of 0.3125. If we substitute this in this or this, are we going to get the same thing? Let's have a trial. The first one, this 240 There is a mess here. Mm-hmm. 240 times 240 divided by 75. 768. Now let's have 0.3125 times 0.3125 times 768. 2 forms 0.3125. So I have confirmed that if you substitute, if we go by the first formula, then if we say P is equals to VI, when we have got this one as 0.3125, then we shall have 240 times 0.3125. We are still going to get 75. And if we use the second formula, our P is equals to I squared, that is 0.3125 squared, then times resistance of 768, then we still get 75 watts. So it is correct in that manner. And now I can continue to the next question, which is the figure below shows how a distant object, is focused in defective eye. It uh, is focused in a defective eye. So if you look at this one, we are having a ray from very far, meaning that it's a distant object. But the image is formed in between the eye in this position. This means that this person can see clearly what is near and not what is far. And then this is said to be short sightedness. So, short sightedness. So, this is where one can see clearly only close objects. But the distance ones, then we'll have this problem at the center of the eye. Then, how can this one be rectified? Suggest a suitable lens that can be used to rectify these defects. Then, if we diverge more these rays, if we apply a diverging lens like this, then we'll be able to diverge the light rays somewhere here, and then we'll be able to focus our image at the retina. So we go for a diverging lens or a concave lens. Like that. We have a chart. It shows an experiment of different parts of electromagnetic spectrum. We have radio waves, we have A, this is supposed to be infrared. We have visible light, we have B, we have X-rays, we have gamma rays. Then you are told name the radiation represented by B. All of these radiations, they are supposed to be 7 in numbers. They are supposed to be 7 in numbers. So we have radio waves. Then from radio waves, we come to microwaves. We have infrared, visible light, UV. We have X-rays, and we have the gamma rays. But we have a point to note that from left towards the right, then we have a decrease in wavelength. And decrease in wavelength in this direction. And still in the same direction, we have an increase in frequency. Still in the same direction, we have an increase in frequency. So we are having this one as UV radiation, So kindly note of these variations that I have given on the board, that towards the right, we have a decrease in and we have an increase in frequency. we have an increase in frequency. So gamma rays highest frequency and they have the lowest frequency. Whereas the radio waves have the highest wavelength with the lowest frequency. Why? This is because all of them share a velocity of 3.0 times 10 raised to power 8 meters per second. So what changes? An increase, sorry, an increase in frequency automatically leads to a decrease in wavelength. So allow me right here. So since V is constant and this is the way to get the velocity, an increase in wavelength automatically leads to a decrease in frequency. Then an increase in frequency automatically leads to a decrease in wavelength. Name and device that can be used to detect radiation air, which is the microwaves. We can go that one very straight without much questioning. We are having a diagram on capacitor network. The diagram is very clear. Then you are told determine the charge stored by 1.5 microfarad. So allow me do some changes on the diagram. That this is 3.0. It is 3.0 microfarad. And at the top here, we are having 2.0 microfarad, like that. And then it is supposed to be having a potential difference of 10. So here we are supposed to be having a PD of 10, like this. So you are told determine the charge stored by the 1.5 capacitor. Then the first step is you get the total capacitance. So for the parallel capacitance in the parallel parts is given by 2 microfarad plus 3 microfarad. You arrive at 5 microfarad. Now C total now will be given by, we have an effective of 5 microfarad and then it is in series with the 1.5 microfarad. Then you can say, if we pick this one to be now the C1 and this one to be the C2, then you can say C1 times C2 over C1 plus C2. So it becomes 5 times 2 divided by 5 plus 2. This gives us 7 of, that is 10 over 7. Sorry, somewhere we are messing. That is 5 times 1.5. And this is plus 1.5. You arrive at 6.5. The top one, I don't know why I'm forgetting, is supposed to be, or from the total computation, we are supposed to get 1.15 microfarads. 1.15 microfarads. Then the next step, Then in our next step, now we understand that charge, the total charge is given by total capacitance times total voltage. And in this case, we know that from the way the arrangement is, since charge is the one that is responsible for current, then for this case, this will be the arrangement. This and this will be 5 microfarads versus 1.5 microfarads, like this. So the charge stored here is the charge stored here. Therefore, if we get the total charge, then we'll be getting the charge that will be stored in each device, in each capacitor. So this becomes 1.15 microfarads times 10 volts. This gives 11.5 microcoulombs. 11.5 microcoulombs, like that. So can say Q at 1.5 microfarads is equals to 11.5 microfarads, like that. Why? The charges will be the same, since 5 microfarads and 1.5 microfarads will be in series. Then now we can move on to the next question. We are having a nuclear reaction in question 12, where you are told below is a nuclear reaction. Let me do some changes. We can have this one as K, and then we leave this one to be R. So you are told identify K. So in short, let me try to magnify this one for you. This is 232 of 90, element A, undergoing a radiation of K to form 228 of 88B, and then it has undergone another radiation of R to form CY 88. I think the correct way to write this one is supposed to be in this manner. It's supposed to be Y of 88 of C. So now you are asked about the radiation K. So from A to B, we can see the mass number reducing by 4 units, whereas the atomic number reducing by 2 units. This represents helium, and helium stands for alpha radiation. It stands for alpha radiation. Whereas from B to C, we can see the atomic numbers are maintained, meaning that the only radiation that can we have somebody by Joseph Muteru is asking if we are having connection to the leakage. We just work by faith that things will fall in parts. Thank you so much for tuning in and to our channel. So the only radiation that can lead to maintenance of this one is where we are having the electron, which is 0, then -1 at the top. So if you pick 228 and 88 plus -1, 0e, then this one is supposed to do what? Is supposed to so this one is maintaining, okay, 88. So what are we supposed to be having here? This is 228 plus -1. So we know that it is supposed to increase by 1 unit. It's supposed to increase by 1 unit, so it becomes 220. So there might be a slight confusion here, and allow me erase that confusion by giving another format of explanation. So for us to come to this, then it's supposed to be 228, 88 of B, then we are forming Y of 88C plus -1, 0E. So how are we going to get Y? That the right hand side must be equal to the left hand side. Both mass numbers and atomic numbers. So 88 and 88, they are very much correct. But what will we do here so that we have y minus 1 to get 228? This one will carry out and have 229 automatically. So that it be 2 at 228, which is left hand side. So the value of y becomes 229 in that manner. We're having a question 13. Draw a circuit diagram to show a P and N junction diode in the forward biased mode. But before then, have a look at this. Back to the session. So we are supposed to have a forward biased mode. So let me draw the P and N junction diode first. Like this. So this is P N. And then the P is supposed to be connected to the positive terminal, whereas the N to the negative terminal. like this. Or we can still have another format, or we have this sign. Like that. So either of the two will be showing what we are being asked in the question. Allow me to just do some sharing. Okay. State one application of the diads. This one will just be a matter of stating, and therefore there will be no big issues. Since you are told just state only one application, then during exam time, you are supposed to state only one. But because now we are in just mode of revision, I can state several. So one, in rectification, and we have in voltage regulators. Uh, those three, those two, sorry, they are enough since the question is tied to only one. We're going to proceed now to question 14, where you are given a certain ray of light and then this prism, and then you are expected to show what will be falling on the screen. Supposed to show what will be falling on the screen. What will be falling on the screen? So allow me work out on anyway, but as long as you can and you can see what is shared on the screen, then seeing me is that much important. So let's go on. You're given this ray, and then you are expected to draw something on the screen. It to be refracted through the prism. So it is going to be split in this corner. This is how it's going to be split. So we shall have the 7 colors. My drawing may not be that much accurate because of the nature of where it can be like that. So this ray is refracted like this, and then it is being split into the 7 colors, having the red at the top and violet at the bottom in that manner. So all the color from the bottom in this manner. This is red, orange, yellow, green, blue, indigo, and this is violet. The splitting of the white light. What color will be observed if the screen was replaced by yellow light? Yellow light, since it will be moving in its own speed, it cannot variation. Therefore, what we expect still to be still yellow, since it cannot be changed. So it is still remains to be yellow. Why? It cannot be split. Yellow color can't be split. But if you're having the white color or the white light, it can be split. We have now, maybe before I move to the next question, I need to warn those who are waiting for the exam that they need to understand how to keep explanation question of testing nowadays in the theory paper has shifted into theory explanatory question rather than theory calculative questions. Therefore, do not be worried the moment you find that most of the work is having explanatory questions. So we have our air-water interface in this manner. Then you are told determine angle Q, which is this one here. I thought to identify it. Then the first thing is you calculate the refractive index of water with respect to air. So the first thing for this diagram, the refractive index of water with respect to air will be given by the sine of incident angle, which is 42, over the sine of the reflected angle, which is 30. And this will lead us to 1.34. So our refractive index of water with respect to air will be 1.34. 1.34. Now, through the principle of reversibility of light, now we are changing the direction of the light. So now the incident ray is from water and then it is getting through air. That is why you can see we are having the direction change in this manner. Therefore, the refractive index, when it is reversed, then it's supposed to be the inverse way. Therefore, the first thing you need to get is the refractive index of now air, since it's the last one with the refracted ray. So the refractive index of air with respect to, which will be the same as the inverse of the refractive index of water with respect to air, like this. Therefore, this 1 over 1.34. 1 over 1.34. Then, now to substitute and say that the refractive index, this one, will be given by sine 25 over sine Q. Therefore, we can say the refractive index now is 1 over 1.34 1 over 1.34 is the same as sine 20 will be the same as 1.34 sine. Get the inverse, the sine inverse of the constant q as 34.5 degrees. 34.5 degrees. We have from and two, state one law of refraction of light. One law of refraction of light. And we finish this part at that end. So that's question 15, and the rest we continue probably tomorrow. So state one law of refraction of light. We have basically two, and remember this is refraction. So the first one is the incident ray. The normal, the refracted ray, all lie on the same plane at point of incidence. And then you need to talk of a refracted ray. Then the last one is that the ratio of sine of incident angle to sine of refracted is a constant. One condition necessary for total internal reflection to occur in prisms. From an optically dense medium Then number two, thank you for all tuning in. May God bless you. Of our 5 weeks program over the December holiday. Welcome all, invite a friend. Don't hesitate, make a call, WhatsApp me through, and then you shall be at the right place. Any inquiry is highly welcomed.